Every year, over 200 programs submit action plans for review. Each one needs expert evaluation, checking feasibility, timeline, alignment with goals. That's hundreds of hours of expert time we don't have. What if we could automate this? Large language models can read and evaluate text in seconds. The technology exists to process all of our 200 plans overnight, freeing experts for the work only humans can do. But in our early testing with naive zero-shot approaches, they yielded overly harsh mechanical evaluations, achieving only 46% agreement on simple pass-fail decisions, not random errors, systemic disagreement. Here's the deeper problem. Even experts don't perfectly agree. For one program, 5 reviewers' scores ranged from 1 to 4 out of 5, a full 4-point range. The rubric uses words like adequate and feasible, words that require interpretation. Different experts interpret them differently. Can we calibrate AI to match how humans actually judge? Not just what the rubric says, but how each expert interprets it. The simplest approach: just give the model the rubric, give it the action plan, and ask for a score. This is simple, but as we saw, can lead to systematic bias in the evaluations. Let's say the rubric says level 3 is adequate, that it meets minimum standards, that it's feasible but needs improvement. But adequate and feasible is subjective. The model interprets these based on its training data, patterns that may not match how your specific experts may use these words. There's a difference between describing a task and demonstrating it. What if we could instead show the model what we mean? We can add 10 examples, real action plans that humans have already scored, with explanations of why, such as a score of 2 means that it's missing key details, a 3 because it's adequate but needs more metrics, a 4 because it has very clear goals. Now the prompt is not just describing what to do, but it has demonstrations of how. With these examples, the model scores align with rubric judgment. The same rubric, same model, but now it understands what you mean. Pass-fail agreement jumps from 46% to 89%. But this raises a question. Different experts have different standards. Shannon tends harsh, Olivia may be lenient, Daniel's balanced. Whose example should we use? If we pick one rater's history, we're calibrating to one perspective, possibly ignoring others. But we don't have to choose. We've accumulated a rich archive, which experts have rated which action plan with what score they gave. We had in our development set 176 programs with 259 expert ratings, not just scores, but patterns of judgment. Each rater has their own history, their own track record of how they apply the rubrics, the patterns that define their judgment. Let's say we use 10 examples from Shannon's history. Now the model isn't calibrated to humans in a generic sense, but it's calibrated to Shannon's specific judgment patterns. We call this a persona, a virtual version of Shannon, not replacing her, but scaling her perspective. Do this for each expert. 5 raters, 5 personas, each calibrated to their respective histories. A panel of virtual experts, each with their own learned perspective. The same action plan goes to all 5. Each evaluates it independently, according to the learned standards. They don't all agree. Shannon, Daniel, and Indira may give it a 3. Olivia and Adrian may give it a 4. That's not a bug, but it's a feature. When calibrated experts disagree, it tells us something real about the document, the ambiguity in the action plan, not just the model. These 5 perspectives become input to a final model. It sees all the scores, the reasoning behind each one, as well as the original action plan. This reconciliation model doesn't just vote or average, it deliberates, like a panel chair, synthesizing a discussion. It considers where there's consensus, weighs the disagreements, returns to the source text, and synthesizes a decision. Out comes a final score, not a single opinion, but the synthesis of 5 expert perspectives through simulated deliberation. Zero shot gave us a 1, the virtual panel may give us a 3, human consensus is also a 3. There we see the panel matches human judgment where zero shot may fail. The complete system, historical judgments captured through examples, multiplied into 5 calibrated perspectives, synthesized through deliberation. So what does this look like in practice? We saw a pass-fail agreement of 46% of the time with our zero-shot approach. Humans typically agreed 77% of the time. Calibrating to a single persona, we saw 89% pass-fail agreement. With the panel, 91%. But this is just the easy version. The real task is scoring on a 5-point scale. Testing individual personas, we saw quadrated weighted kappas that scattered wildly, the worst of a 0.27, the best a 0.45. Many personas fell far below what we saw with human agreement. If you had to pick just one persona, which one would you trust? The answer, though, is a panel. We take the 5 best performing personas, and when they deliberate together, something remarkable happens. The panel agreement jumps up to nearly 0.5, a 10% improvement. And crucially, the panel agrees with human consensus more reliably than individual human raters do. Why 5 raters? Well, when we calibrated this, we saw that increasing the number of perspectives improved agreement, but with diminishing returns. So once we get to 5, we have the diversity we needed. This approach isn't magic. Each virtual rater requires 10 to 15 examples from the real expert. Performance depends on having diverse quality personas, as we saw, and running 5 models costs about 45% more than a single rater, but for high-stakes evaluation, it may be worth it. The goal is never to replace human judgment, but to scale it reliably. A panel of virtual experts, each faithful to a human's perspective, deliberating together. The result, agreement that exceeds what humans could achieve alone. From 5 real experts, 5 virtual perspectives. From disagreement, consensus. From hours of review, seconds of computation, expert judgment scaled. Want to try this yourself? The code, prompts, and working examples are all open source. Scan the QR code to get started.